Hello everyone, welcome to our video. Today we will present our research about implementation of smart system control of water quality in catfish ponds to reduce crop failure and increase of catfish farmer in DUMAI city. Before that, let me introduce myself and my crewmate. My name is Muhammad Fadan Albani as a leader.
This is Muhammad Izil Islam Zamzami as crew. And this is Bagas Wardana Haryanja as crew.
Developing catfish ponds are an important factor in determining the quality and quantity of catfish. Water condition must be considered to support catfish farming. Good water quality depends on pH, temperature, and clarity. Fahmi and Natalie 2020.
Some diseases suffered by catfish include tail, whiskers, and euchre disease. The cause of this disease is the low quality of water in the pond. The causative factors include not doing pond preparation properly so that the condition of the pond water is not suitable for catfish life.
Based on the background, we have proven we have found a solution catfish farmers and namely that from a tool we can call implementation of smart system control of water quality in catfish ponds to reduce crop failure and increase productivity catfish farmers in DUMAI city. The aim of have improved water quality in catfish farms, get precise accuracy from the sensor users, can increase quality and on the catfish farm.
The method we use in this research is, the first is literature study, the second is tool design, the third is component procurement, fourth there is a prototype or model, lastly there is a testing and evaluation. The first stage, namely our literature study, began looking for the impact of change in water pH in catfish ponds and carried out problem analysis and determined good water condition in catfish ponds. The second stage is the tool design stage. At the stage we can design the physical appearance of the tool and design the block diagram of the tool. Third phase. At this stage, the component we use to create the prototype are: the first is A201 pH electrode function to measure the pH of water. The two MCU nodes function as the brain of the device. The third is PH450C module function as a link between the pH sensor and the MCU node. Lastly, the mini water pump function as a water pump in catfish ponds. And the final stage, testing and evaluation stage. This stage is divided into three parts. First, the pH sensor, both IoT test and overall system testing. The first test is the pH sensor test. This test aims to see water and pH sensor used in function properly. The test is carried out by placing the pH sensor in several samples of the water and comparing the results with the pH measuring paper. The following is a table of pH sensor test result based on the table. Apart from 10 times testing with different water samples, the results were obtained, namely a sensor with an average accuracy rate of 80%. The next step, the IoT test, aims to see whether the system is capable of sending reading data from sensors so that it can be monitored remotely by the user. In this test, the data is set and sent every 15 seconds. The data sent is the pH value of the water along with a IoT results table and monitoring image from user device. In the table below, it can be concluded the system can send notification properly to users. The conclusion we can get from our research is first, the pH sensor has worked well and is able to detect pH of catfish pond water with accuracy value 80%. Second, the water pump has actively worked when the pH was detected low or by filtering the water until pH returned to normal. Final, the tool has been tested on standard artificial pond. pH value from setting is smaller than 7 and big of 8, and system runs according to the algorithm design.